Exercise 4, first question, prove that the following are irrational number. First bit, 1 by root 2. To prove 1 by root 2 is irrational number, we have to assume that 1 by root 2 is a rational number. So rational number means which is expressed as a by b. So 1 by root 2 is a by b because we are assuming it. So root 2 into a is equal to b. Cross multiplication root 2 into a is b and root 2 is b by a. Since b and a are integers, b by a is a rational number. Therefore, root 2 should be a rational number. If right hand side is rational, obviously left hand should also be rational. But root 2 is irrational. We all know that root 2 is irrational number. So our assumption was wrong. 1 by root 2 is a irrational number. 6 plus root 2, we have to prove this is a irrational number. To prove it is a irrational number, we have to take it as a rational number means it can be expressed as a by b, and it is represented as a minus 6b by b, where here a, b and 6 number are integers. Therefore it is a rational number. If right hand side is a rational number, therefore root 2 should be also be rational number. But we all know that root 2 is not rational, it is a irrational. So 6 plus root 2 is a irrational number. Prove root 5 is a irrational number. So let us assume root 5 is a rational number. Rational number means we can express it in a by b or p by q form. So on squaring on both sides, so root 5 whole square is equal to p by q whole square. So square root cancel, 5 is equal to p square by q square. So division goes to that side, will become multiplication. 5q square is equal to p square. We will take it as a first equation, or p square by 5 is equal to q square. Since 5 dividing p square, 5 also divides p. This is by theorem 1.6. So p is a multiple of 5. So we'll take it as a first part of the theorem. Let us assume that p is equal to 5m, where m is a integer. So p square is equal to 25m square, as we are squaring on both sides from equation 1 and 2. So this is the first equation and this is the second equation. From equation 1 and 2 we get 5q square is equal to 25m square, because p square is nothing but 5q square. We are replacing p square from first equation as 5q square. So 5q square is equal to 25m square, 5 ones are 5 5s are. So q square is equal to 5m square. 5 divides q square, so 5 also divides q, again by theorem 1.6. So hence p and q are common factors of 5. In first equation, first part of the theorem, 5 is having a common factor for p, and also in the second part of the theorem 5 is also having the common factor for q. So this is contradiction because our assumption is wrong. Root 5 is rational number, what we have assumed. So this is false. So we conclude that root 5 is irrational number.